giant star in the sky is capable of destroying Earth in an instant, but it is also the only reason we exist. The sun, our constant companion, has captivated humans for thousands of years. But behind its warmth, it's a violent, unpredictable, and awe-inspiring force that shapes everything in our solar system. In this video, we delve deep into the sun's fiery heart, revealing its secrets, hidden dangers, and the cosmic role it plays in keeping our planet alive. In the end, you'll see the sun in a way you've never imagined. What is the sun? The sun isn't just a ball of fire. It's a massive nuclear reactor. Made mostly of hydrogen and helium, the sun generates energy through nuclear fusion, where hydrogen atoms collide and fuse to form helium, releasing massive amounts of energy. Every second, the sun converts 600 million tons of hydrogen into helium, releasing energy that travels 93 million miles to Earth, lighting and warming our world. But this energy isn't light. It's a constant storm of heat, light, and radiation. The core, where fusion occurs, reaches a temperature of about 27 million degrees Fahrenheit, 15 million degrees Celsius. Its surface, or photosphere, is cooler, but still scorching at 10,000 degrees Fahrenheit, 500 degrees Celsius. Imagine a temperature so intense it could vaporize anything in seconds. The structure of the sun. Understanding the sun requires studying its layers. Starting from the inside, core, the powerhouse where nuclear fusion occurs. It is from here that all the sun's energy originates. Radiative zone. Energy moves slowly outward, taking thousands of years to escape the core. Convection zone. Here, hot plasma rises, cools, and then sinks, creating convection currents that drive magnetic activity. Photosphere. The surface we see, studded with sunspots, colder, darker regions caused by intense magnetic activity. Chromosphere and coronal. The outer layers visible during a solar eclipse. The corona, which is surprisingly hotter than the surface, can reach temperatures of millions of degrees and is the source of the solar wind. These layers are not only static, they interact violently, producing solar flares, coronal mass ejections, and magnetic storms that can disrupt satellites, power grids, and communications on Earth. The sun's magnetic nature. The sun is magnetic, literally. Its magnetic field twists and turns due to the differential rotation of its surface and the convection movements beneath. Sunspots, solar prominences, and solar flares are all manifestations of this magnetic chaos. Sunspots. Dark, cool regions caused by magnetic activity. They're not just cosmetic effects. They signal intense solar storms forming beneath the surface. Solar flares. Sudden bursts of radiation that can affect Earth's ionosphere, causing auroras and potentially disrupting satellites. Coronal mass ejections, CMEs. Vast clouds of charged particles ejected into space. If directed toward Earth, CMEs can cause geomagnetic storms that disrupt technology and even pose a radiation hazard to astronauts. The sun's 11-year solar cycle, marked by the rise and fall of sunspots, is a reminder that this star is not static. It is a living, breathing, and explosive entity. The sun and life on Earth. Without the sun, life as we know it would not exist. Its energy drives photosynthesis, powers our weather systems, and keeps our planet at the right temperature for liquid water. But it's a delicate balance. Too close and Earth will burn. Too far and it will freeze. For now, the sun is slowly consuming its hydrogen fuel. In about 5 billion years, it will swell into a red giant, potentially engulfing Earth and sterilizing the inner planets. This makes the sun both life-giving and ultimately destructive, a cosmic paradox that reminds us of how insignificant and fleeting our existence is on the vast scale of time. Surprising facts about the sun. The sun contains 99.8% of the mass of the entire solar system. Its light takes about 8 minutes to reach Earth, meaning we always see the sun as it was in the past. Solar storms can produce auroras so bright they can be seen as far south as Florida. The sun is not perfectly spherical. It bulges slightly at the equator due to its rotation. Observing the sun. We study the sun through telescopes designed to block its intense light. Satellites like the Solar and Heliospheric Observatory, SOHO, and probes like the Parker Solar Probe, which literally flies through the sun's atmosphere to collect unprecedented data. Each discovery reshapes our understanding of stellar physics and the delicate balance that maintains our solar system. But here's the challenge. Despite centuries of observation, the sun still hides secrets that could threaten Earth. Solar storms can disrupt modern technology, interfere with GPS, destroy power grids, and even endanger astronauts. In our interconnected world, a major solar storm isn't just a freak phenomenon, it's a potential catastrophe. Scientists are racing to predict the sun's behavior and protect our planet from its devastating effects. Let's explore the most violent solar events ever recorded. The Carrington Event, 1859. The largest geomagnetic storm in recorded history. Telegraph systems were disrupted. Auroras appeared near the equator, and the sun's wrath became undeniable. Recent solar storms. In 2012, a massive coronal mass ejection nearly struck Earth. Had it struck, the damage to satellites and power grids would have cost trillions of dollars. But these events are also impressive. The sun's immense energy is astonishing. In a single second, it radiates more energy than humanity has ever produced in its history. It's a reminder of the immense power at the center of our solar system and our dependence on it. Now imagine a moment in the future. Billions of years from now, the sun exhausts its hydrogen fuel, expands into a red giant, and engulfs Mercury, Venus, and possibly Earth. While this would be cosmically catastrophic, it is the fate of all stars like the sun. But for now, we are at the perfect distance, at the perfect time, witnessing a star that sustains life and reminds us of the fragility of the balance of existence. This is the sun, not just a light in the sky, but a natural force that determines life, destruction, and the rhythm of time in our solar system. From nuclear fusion in its core to magnetic storms on its surface, the sun is both a source of life and a potential destroyer. It powers our planet, powers the universe, and continues to challenge our understanding of physics. By studying it, we learn not only about the sun itself, but also about the origins of life, the fragility of Earth, and the incredible forces that shape our universe.